Hi, everyone. I'm just going to wait one more minute to get to the top of the hour, and then we'll get started on the webinar. Thanks for being here. Hi, everyone. Thanks for joining the webinar. I'm Dr. Kim Trenbath, and I'm the lead for the Better Buildings Alliance Plug and Process Loads Technology Research Team. I work at the National Renewable Energy Laboratory. I'm hosting this webinar. It's a joint webinar with the PPL team and the Integrated Lighting Campaign out of the Pacific Northwest National Laboratory. Today's webinar is Better Together, Integrating Plug Load Management into Lighting and Building Management Systems. Next. We have an excellent agenda today. First, we'll give our regular PPL team update with some of the new resources that we've developed. And then I'll introduce my colleague, Axel Pearson, who will talk about the Integrated Lighting Campaign. And I'll preface this with, I hope that you apply for this. It's a great opportunity. Then we have two guest speakers, guest presentations. The first one is Mark Maholenbrock from the Minnesota Department of Transportation. And our second presentation is Dr. Jan Kleisel and Keaton Chia from the University of California, San Diego. After this, we'll wrap it up with Q&A. I want to put a note in about the Q&A. Anytime that you have a question throughout the webinar, please type it into the Q&A box. We're not going to be responding to the Q&A box per se, but we are going to be collecting all the questions on the back end, and we'll be responding to them during the Q&A session. So please, as we go, type in your questions into the box. And if we don't get to your questions, we'll respond to them in the transcript that we send out after this call. The materials that you see today will be sent out after this call as well. Next. I want to introduce my PPL team. This is my team from the National Renewable Energy Laboratory. We're based out of Golden, Colorado. I'm the lead, and then we have two research engineers, Amy Labar and Omkar Gapande, and our project manager who dabbles in research as well, Robin Tuttle. You can reach us at ppl@nrel.gov. Robin is always monitoring this website or this email, so we will get back to you as soon as possible. Next. Now we'll go into a PPL team update with some of the resources and things that we've developed over the past couple months. Next. You can get all of the resources that I'm going to be talking about here on our website. The link is at the top. And on our website, we have links to information about PPLs, how to control these PPLs in your buildings. We also have links to recordings, and I'll go over that in a little bit. Next. I'm pleased to say that we have a new fact sheet. This is on the automatic type and location identification system. This is a technology that was developed by NREL, and this is for commercial building plug load management. The Atlas system is a plug and play system framework, and this framework tracks devices, your plug-in devices, as they move throughout the building. It accurately applies controls no matter where your device is. It'll apply the correct controls, and it monitors your device energy. You can learn more about this technology in our featured solutions section on our webpage, and you can download this fact sheet. Next. Another announcement that I would like to make is that we have updated our utility incentive lists. This list has over 500 PPL incentives from over 42 states. So this is an Excel spreadsheet that you can download from our website, and you can filter by your state as well as your utility. And PPL incentives include those that deal with appliance and kitchen equipment, advanced power strips, computer power management, occupancy sensors, vending machine controllers, and there's also a category for the whole building. This is an updated spreadsheet, and so if you click on the link here on the spreadsheet, on the slide deck that you'll get, you can get these this utility incentive list. So you never know what incentives you'll be able to take advantage of in your area, so check it out. Next. NREL was participating in a group of national laboratories that developed PPL resources or resources for building owners related to the low carbon strategies. And these are guidance documents, and we included our PPL strategies in these guidance documents. They are featured on the Better Buildings Alliance website, link here. And I want to give a shout out to our kitchen resource because we led the development of that. Next. Like this webinar, which is being recorded, you can access all our recorded webinars on our website. Here's a list of 3 of the most recent ones. The link at the top shows you, gets you to the link where you can access all of them. And these webinars are really useful. You can watch them to learn about the guest presenters and how they've reduced their PPLs in their buildings. The first one here is a presentation that we did for the low carbon peer exchange. And this is a unique presentation because the PPL team did this presentation and featured all the solutions that we have for controlling plug loads in your building, including your management solutions as well as your engineering solutions. The middle option, or the middle webinar here was presented by the Community College of Allegheny County and Cornell University. And in this, these 2 building owners talked about low to no cost strategies for plug load controls in their buildings. And then last but not least, we had the Houston Advanced Research Center present on how they are getting to net zero energy through strategic management operations, as well as plug load management. And they were talking about how they use some smart outlets to control their plug loads. Next. And the final resource that I would like to feature is a new fact sheet. We are featuring the Minnesota Department of Transportation Cedar truck facility on this fact sheet. And in this presentation today, you'll hear about a lot of the strategies that Mark has used to control his plug loads at the Cedar truck facility. So he's going to present on the information that we also have on this fact sheet, but you can download the fact sheet to get a quick snapshot of what he has done. Next. And I always like to give a little bit of an update on some of the projects that the PPL team is working on. This year, 2 of our main projects are listed here. We are working on automatic reciprocal controls and transforming the market here. This is a technology that exists. We're working to increase market uptake for ARCs. And the other project is we're supporting the Department of Energy on energy efficiency in medical imaging equipment, specifically MRI machines. Next. That's all the update that I have today for the PPL team. You can contact us at ppl@nrel.gov. My information is here, and then our website is also on the slide. Next. Okay, so I'm going to turn it over to the next presenter, but first I would like to introduce Axel Pearson, and he's going to talk about the integrated lighting campaign. Next. My colleague Axel Pearson is an energy efficiency project manager at the Pacific Northwest National Laboratory, and he supports the technology adoption team with a focus on energy efficient lighting and controls. Axel's experience includes leading the solid state lighting program for the Design Lights Consortium. He has a master's degree in environmental management from the University of San Francisco and is lighting certified by the National Council on Qualifications for the Lighting Professions. I'll turn it over to Axel.
Thank you, Kim. Next slide, please. So, well, yeah. Hi, everyone. Thanks for having me. Thanks for letting me talk a little bit about the integrated lighting campaign. Again, my name is Axel. I work at PNNL. This is going to be a very quick overview of the campaign, but I hope I pique your interest today. And if I do, shoot me an email for more information. I'd be happy to chat and tell you more. My contact information will be displayed at the end of the webinar. Next slide, please. Right, so just like the name sounds, the integrated lighting campaign recognizes installations of integrated lighting, which means that the lighting system can communicate with other building systems to enhance building performance. Today's lighting has come a long way from basic LED retrofits. It can talk with the rest of the building to achieve those deeper energy savings at the building level, for example, by exchanging information with the HVAC system, or, as we're talking about today, controllable plug loads. Lighting and lighting sensors hold some valuable real estate in the building ceilings. And when I say that, I mean like a bird's eye view of the space. They can really see everything that happens. And then they have the ability to relay that really useful information to other systems like occupancy information, ambient light, temperature and humidity, location of different assets around the building. So again, very valuable information. But that is not all. Oh, I see we advanced one slide. Can we go back? That is not all the campaign is interested in. There are still luminaires and luminaire control systems that we're hoping to capture in the campaign as well. Advanced systems and controls and lighting that improve the lighting performance are definitely of interest. And we would love to hear how some of those systems go above and beyond, very basic occupancy sensing or scheduling approaches. In particular, where sensors and controls are enabling, again, those deeper operational energy savings or creating, enhanced occupant lighting experience. That could be luminaire level lighting controls, also known as LLLC, or white tunable lighting systems that have a positive impact on the circadian system of the occupants. So again, through the ILC, we're hoping to learn about and recognize some of these really innovative lighting projects that are going on. And so if you know of a project, please let me know. I'll tell you a little bit about recognition on the next slide. So there are categories of recognition to those innovative and advanced lighting projects. There are 6 main categories shown here, 2 of which are new this year. There's the advanced use of sensors and controls for connected lighting systems, networked lighting controls, LLLC or white tunable systems, stuff I just mentioned. Then there are 3 separate categories for integrated systems. Integrated controls for plug loads, again, what we're going to be talking about today, HVAC, and other categories that look for lighting. Look to the lighting system to help inform those building systems, and that could be automatic shades or solar panels or grid services or security or something like that. Lots of options with other integration. As I mentioned, there are 2 new recognition categories this year for participants. There's integrated lighting and horticultural controls, which could be some integration that optimizes energy efficiency, improves crop yield, reduces the use of water or chemicals or pesticides within a grow facility. The other new category is innovative maintenance, operation, and financing service models, and that could include lighting as a service, unique utility incentives, or alternative financing options. So if there's a project that you are aware of that employed one of these tactics, let me know. I would be happy to talk about the integrated lighting campaign more. Next slide. I want to give you an idea of a case study, and this is very similar to the one that Kim showed up on the slide earlier about the Minnesota Department of Transportation. This is another case study that we developed as part of the campaign recognition. Bryan Health is a healthcare campus in Lincoln, Nebraska, and they upgraded their interior lighting from fluorescent to LEDs with advanced controls employing comprehensive management lighting system equipped with occupancy sensors, task tuning, preset lighting scenes, and the ability to kind of remotely control the building throughout the system. And this is what they were recognized for. So not only did they get a serious boost in energy efficiency, the staff were happier with the control over their lighting. They saw reduced support calls with shorter response times and really better diagnostics to identify problems with the lighting system before they were reported. We have a number of other case studies published and more on the way, so keep an eye out for those. Next slide. All right, again, if you know of a project or know someone who might be interested in being recognized by DOE, this is the form you or they would fill out. Really, this is about telling the story of your project, how it fits into those recognition categories, and then you could provide some data such as number of buildings, energy savings, incentives received, or other quantifiable information that supports that story that you're telling. You can see here at the top of the slide that submissions for recognition are due next week. Well, they were, but we have just decided, since we're getting some really good interest in the program, folks have asked for more time. So we've extended the deadline to April 15th. So get those submissions in, let me know how I can help. And that is all I have. Thank you again to the Plug and Process Loads team for giving me a few minutes on your webinar to talk, and thank you for listening in.
Excellent. Thanks, Axel. Next slide. And here's Axel's contact information, axel.pearson@pnnl.gov. Next. All right, now we'll get into our technical presentations. Next. Our first presenter is Mark Mulholland-Brook from the Minnesota Department of Transportation. Mark is the energy engineer for the Minnesota Department of Transportation's Building Services section, where he manages energy and greenhouse gas reduction projects and strategies for the Minnesota DOT buildings throughout the state. He received a bachelor's degree in mechanical engineering from the Minnesota State University in Mankato in 2003 and spent 10 years working in the commercial facilities maintenance field. All right, Mark, I will turn it over to you for your excellent presentation.
Thank you. Thanks for having me. Yeah, I am Mark Mulholland-Brook with MnDOT, Minnesota Department of Transportation. I figured I'd steer into the stereotype and put a fishing picture up for a Minnesota person. So next slide, please. Yeah, I have a little project that we did at a truck station of ours, and the PPL people were, they invited me to speak about it. So next slide. Talk a little bit about MnDOT's buildings first, just as kind of an introduction. People think of MnDOT, and we're mostly involved in design, construction, and maintenance of highways. So most of our facilities support that work. We have 18 regional headquarters, 137 truck stations, and 68 rest areas, along with a lot of other special service sites. And here's some pictures of two of our prettier buildings. But if you go to the next slide, there's the Cedar truck station. Not quite as pretty. The clouds came out when I took the picture, but it's a pretty important facility for us. It's a base of operations for road maintenance in the South Metro area near the airport. There's a lot of traffic there. There's a lot of very important arteries that they maintain. So it's a good sized truck facility. Most of it is basically a garage area. There's also a mechanics shop, but the area where the project that I'll be discussing today took place in is the office area, which is about 11,000 square feet. It's mostly some offices and cubes. There's a conference room, lunch rooms, storage rooms, and restrooms, locker rooms. Next slide, please. So the main garage area of the facility had already been upgraded to LED lights, but in this office area, we had the existing linear fluorescent fixtures that were original to the building. And the facility managers were having to deal with them being at the end of their life anyway. The ballasts were failing and, constant relamping. The other attribute about this facility that was always on my mind is the fact that the HVAC was scheduled to operate 24/7 because of the nature of the operations at this facility. People are coming and going at all hours of the day. So they never really wanted to shut off the HVAC system. So I figured it would be a good opportunity to integrate the lighting with the HVAC, and in this case, the plug loads as well, to take advantage of some of those occupancy detection functions. Next slide, please. So how this came about is Xcel Energy distributed a flyer to our Office of Enterprise Sustainability, and the flyer was put together by, it was called Seventh Wave at the time. They changed their name to Slipstream. It's been a couple of years. And Slipstream had received a Department of Energy grant for integrated lighting retrofit projects. They worked with Xcel Energy, who is a major local utility here, to disseminate the to possible participants. And they got products from Cree Lighting and LeGrand for the lighting and plug load, respectively. And they also provided the design, the lighting design, and the HVAC integration, plug load integration design. And they happen to work with PNNL for pre and post project measurement and verification. Next slide, please. So our truck station fit in perfectly with the requirements for this pilot project. First of all, we have an executive order to reduce energy consumption at all state buildings by 30% by 2025. So we always have a desire to save energy. Our square footage range of the office area was right what Slipstream was looking for. And like I said, we had fluorescent fixtures near the end of their life. Another thing that this site had going for it is we had recently had an automation upgrade done at the site. So it had new backnet controls for the HVAC. And also, like I said, there's highly variable occupancy. So this is a perfect site for taking advantage of occupancy detection and integrating it with plug loads and HVAC. Next slide. So here's an after picture. I didn't have a good before picture, unfortunately, but what we used were the Cree luminaires, called a SmartCast. But what they do is they basically can communicate with each other wirelessly to create virtual lighting network zones. So in this area, for example, it's a large area that would be one occupancy zone, but kind of off to the side of this picture, there are small offices, and each one of those would be an occupancy zone too. And those occupancy zones could communicate wirelessly with both the plug loads and with the HVAC. And it's all set up virtually and wirelessly. Next slide, please. So how that is done is the Cree system came with this configuration tool, and you literally just point it at the fixtures and it could communicate with it. It would detect all of the fixtures and luminaires that were in the area, and you could group them by zone and communicate with them that way. And that's also how the switching was commissioned as well, and the lighting level detection, all that kind of thing. On the right is a control schematic that shows specifically how the plug load was integrated with the lighting zones. On the bottom, it says occupancy sensor. That could be grouped with the other occupancy sensors that were integral to the luminaires and included in the occupancy zones. And it would communicate via a relay in the control module to the LeGrand signal pack transmitter, which communicated wirelessly to the plug loads to the receptacles. Next slide, please. On the left here, we have an image of what the controlled receptacles look like. On the top is the RF transmitter that communicates directly with the receptacles. And on the right is the integrated portion of it that communicates with the occupancy zones. And within that control module is a relay that sends the message to the LeGrand controllable receptacle transmitter. Next slide, please. So basically how the installation went is that the electricians installed the controllable receptacles concurrently with the lighting. There's a button on both the receptacle and on the transmitter that is used to bind the receptacles to the transmitter. So I think the commissioning process was basically hold down the button on the transmitter and then go find all of the receptacles that you want paired with that transmitter, hit the button on them, and then go back and hit the button again on the transmitter, and they should be bound. So when that transmitter gets the control signal from the SmartCast relay, it will turn the receptacle on and off. Next slide, please. Okay, so the commissioning process, tested the binding between the RF transmitters and the receptacles, just to make sure that it was bound to the correct receptacles. Tested the occupancy detection. What I basically did to do this, it was kind of low tech. As it were, this project was being commissioned about the time the first wave of COVID was happening, and the pre-commissioning agent was located in Las Vegas. So I had to do a lot of this myself when I normally wouldn't. So I got to be a little bit more intimately familiar with it than I really wanted to be. But to test the occupancy detection, I basically ran extension cords to some fans and lights and things like that, and walked into the room. And when it came on, I knew it was turning on properly, and then I had to leave the occupancy zone. And that's why I had the extension cords. So I could kind of peer into the room, and if the fan turned off in 10 minutes, I knew it was working properly. So there might be a more sophisticated way to do it, but I was kind of just trying to make it work. So, and then the big part of it was making sure that the proper equipment was plugged into the correct receptacles. So there were a couple of refrigerators I was a little bit nervous about, but we made sure it was plugged in correctly. So next slide, please. As far as user engagement, it was important to keep the building occupants in the loop, so they knew this was coming. It was a lighting retrofit project, and that was obviously pretty visible, so they knew that was happening, but I had to inform them that we were also doing this plug load part of it too. So they had a lot of opinions about what should and shouldn't be plugged into these controllable outlets. I also distributed this flyer that LeGrand had given me to the supervisors so that they could distribute it to their people. Also, it was important on return visits to find out about problems that were happening. And I made a lot of return visits, like I said, more than I intended to. So they got to know me pretty well. And as soon as I walked in the door, they usually have a couple issues for me to address. Big deal for them was the TV would turn off if they were in the back of the break room. So we had to make sure that that occupancy zone was made large enough to include the entire break room. It was a really big break room. So I had to expand that occupancy zone. Next slide, please. I feel like I'm missing a slide here, but anyway, energy savings. Yes, Michael Meyer had given me this information here. Most of the energy savings came from the luminaires and the HVAC. We didn't really have all that many outlets installed in this case, but you know, there was a real amount of savings here, as you can see. $1,600 in material cost and $500 in labor cost. But in this case, we didn't have a whole lot of controllable outlets, but this is a pretty good example of what could be done in a larger facility. Next slide. Okay, here's the one I was looking for. For best practices, choose the controlled equipment wisely and don't overreach. Computer monitors and fans and the little bits of equipment that are scattered around offices, that usually works pretty well. And like I said, we had to be kind of careful with the TVs, and there was some other AV equipment where we had a similar problem. The occupancy zones initially weren't large enough to capture all of the users. One failure we had was a vending machine. We thought, hey, that, you know, it's not a refrigerated one. Let's put that on the controllable outlet. But it turns out that there was a boot up time of a minute or two. And you know, these hungry people wanted a candy bar, and the candy bar they had to wait for, they were not too happy about that. So we kind of gave up on that one. Another best practice is to keep open communication with building occupants so that these problems can be solved quickly before they get upset. And I kind of got lucky on this one, that I just happened to be there all the time. So it didn't become a problem, but I could see how it could have been a problem if I wasn't communicating as fully with the building occupants as I was. Another point I want to make is make sure the electricians understand the scope of the work. Another case here, I kind of got lucky. We had a good electrician who just kind of commissioned these programmable receptacles on his own. He didn't really need us to tell him that it was part of his work scope. But when I looked at the amount of work that he did, it wasn't really, he could have made the argument that it wasn't really in his work skill, but it worked out well for us. But it's just something to keep in mind for future projects. And another one, it didn't really come into play on the controllable receptacle part of it, but it came into play on our HVAC side, is that if your lighting network is connected to other building networks, make sure you have your IT people involved early, because they didn't have all the information they needed when we tried to integrate the lighting system with their HVAC system. And it ended up being kind of an involved process to get through some firewalls and things like that. So that's my final best practice. Next slide, please. That might be the end, huh?
Yeah.
Thank you.
Hey, Mark, thank you very much for your excellent presentation. This is a great example of how to implement integrated lighting controls with plug load controls in a facility. And some of the best practices are really valuable. So thanks for sharing those with us today. And then again, everyone, you can access those best practices on our fact sheet, or you could access these slides after the call. We'll have them available. Okay, great. Thanks, Mark. And so now I'm going to move on to our next presentation. This presentation is from the University of California, San Diego, where they've integrated their plug load controls with their building management systems. And I'll introduce Dr. Jan Kleisel and Keaton Chia. So Professor Kleisel researches the interaction of weather and with engineering systems in buildings, solar power systems, and the electric power grid. Dr. Kleisel received an undergraduate degree from the University of Stuttgart and a PhD from Johns Hopkins University, both in environmental engineering with a focus in environmental fluid mechanics. He's the director of the UC San Diego Center for the Energy Research and a professor in the Department of Mechanical and Aerospace Engineering. Keaton Chia is a research and development engineer at UC San Diego. He works on the DER Connect project, a test bed that enables researchers and industry to achieve a better understanding of how to integrate renewable energy resources into the power grid. With a background in mechanical engineering from UC Berkeley, he is also involved with adjacent research related to plug load control and integration into building management systems. I'll turn it over to Dr. Kleisel and Mr. Chia.
Cool. Hi, everyone. Thank you so much for this opportunity to share about our project here at UC San Diego. Next. And we can do one more slide. So again, my name is Keaton Chia, and I'm here with our principal investigator, Professor Jan Kleisel. And I would also like to acknowledge the contributions of our team, primarily undergraduates here, along with one master's student. Next. Our project is part of a grant from the California Energy Commission, and the purpose is to demonstrate the added value from integrating these plug load controllers into a building energy management system. Next. So you can imagine some benefits that can come from this integration. By integrating your HVAC systems, lighting, and these plug load controls, you can have a single user interface to see all of these different systems. You can also extend the reach of your BMS. So if you have standalone AC units in individual offices, now you have that integration of those into your system. There's also a sharing of data between systems, and this can lead to greater energy savings. You can also gain insights into energy consumption and space usage, as well as some non-energy benefits, such as identifying redundant equipment or equipment degradation and other power anomalies. Next. For our project, we have 4 objectives. The first one is to see a 20% reduction in building plug load energy use. We're also looking to instrument at least 9 of our buildings on campus. Looking for a simple payback of less than 5 years. That's something we'll be evaluating as we go through this project. And lastly, to also automate the configuration and reconfiguration of these plug load controllers. Next. The project is broken up into 4 different tasks, and it's a collaboration with several industry partners. Of course, we have support from the California Energy Commission, as well as NREL. Our first industry partner is BERT, Best Energy Reduction Technologies, and they're responsible for task 1, the deployment of these plug load controllers. And we're about 70% complete with that, so that's still in progress. Johnson Controls is responsible for task number 2, the integration with the building energy management system, and we're almost about 50% done with that. And then our team here at UC San Diego is responsible for task 3 and 4. So 3, we're just starting the advanced plug load operations, and then at the completion of our project, we'll be publishing the benefits of the project as well as best practices. Next. For task number 1, the plug load deployment, our first step was to identify our buildings to include in scope. We primarily focused on buildings with office type spaces and those type of departments. So we generally avoided any laboratories with any health and safety critical equipment. Next, we went in as a team to survey those buildings and identify which plug loads we could control. And we received a list from BERT as well as their team came out to do that survey of typical loads that you could control. So ranging from printers to coffee machines and water dispensers, TVs. After that, there was a whole bunch of emails sent out to different departments for their approval and to schedule the installation. And when it came to the actual installation process, the first thing we did was to take the MAC addresses from these different devices and then to register that with our IT department. So there was a tight coordination with them. We also added stickers to the different devices. So each device had a label with our email address set up specifically for this project. And then you can see how we have stickers on the devices as well as on the cords. And that was really helpful for navigating the spaghetti mess of different cables and knowing which ones were the correct ones to plug in. We also found that having really short extension cords was really helpful. You can kind of see that power strip in the middle there and how, again, typical in most offices, those outlets are viable and typically pretty full. So having a short extension cord allowed us to plug in these smart controllers in, since they do kind of cover up other outlets in some cases. Once we installed it, we did verify that it connected to our servers. We were getting a good connection. And then we would also log information about that plug. So knowing what load was plugged into it, the room number, and some occupant information to be able to contact them if needed. We did start the installation during COVID. So at this period, the campus was pretty empty. And a pro of that was it made it really easy for us to go in and do our work without distraction. However, since then, of course, it's been quite challenging because we've seen departments move and occupants move between offices. Of course, there's the scheduling as well. So people have hybrid schedules and have kind of changed what loads they actually need in their office now. So there's a lot of things we're having to adapt to. Next. This is the smart plug that we're using. It's something you can plug into the wall. So rather than using a smart outlet, this one, it's very easy for us to just plug right in. It does connect over the Wi-Fi network. It lets you turn the relay on or off, provides metering, scheduling, a power threshold, which is handy. So you can input a threshold and the smart plug will only turn off if the power measurement is below that. So if you have a printer that's actively printing, it won't cut off right in the middle of that printing session. It can also measure temperature. And there's 3 ways to interface with it, which makes it very adaptable in a sense. There's the BERT software from BERT. It has a backnet gateway, and then there's also a RESTful API provided as well. Next. This is an overview of our deployment. We're deployed across 14 different buildings on the UCSD campus, across 59 different departments, ranging from enrollment through anthropology, athletics, medical education, and computer science. So we're getting a really diverse range of uses and kind of behaviors with these smart plugs. Next. Currently, we have 744 plug controllers installed with the goal of getting over 1,000 deployed on campus. 140 of those are monitoring computers just for energy consumption purposes only, so no control. And that leaves us with 604 controllable loads currently, again, ranging from printers to TVs and Keurigs. Printers being the bulk of the loads that we have controlled right now. Next. And here you can see a distribution across our different buildings. Kind of the high peak there is Geisel, our library. And then the second one being student services, which from the sound of it, again, is more of a business-oriented departments. For the other buildings, we're typically seeing between 30, or an average of 35 controllable loads in those buildings. And again, we're in mostly office settings or open office settings with cubicles, with a minority in classrooms and conference rooms. Next. Task 2 is the integration into the building energy management system. And this shows you an architecture of that integration. So on the left, you have the smart plug, again, communicating over the wireless network to a backnet gateway or a server running that BERT backnet gateway. This then creates a virtual backnet object, which can be discovered by the Johnson Controls virtual network automation engine. This is lastly then integrated into the actual building energy management system, the Metasys Site Supervisor. Next. This gives you an overview of what that site supervisor looks like. And so our facilities managers have access to this, and this is where they would manage all the different NAEs on campus. So you can see that huge long list. Those NAEs are typically what control the VAV boxes, your air handlers, those type of building systems. And now you can also see the smart plug controllers in here. Next. Johnson Controls also has a graphical user interface. So here you can see the entire campus. And if I were to click on a building, next, you can see, for example, here, Center Hall and the different floors of Center Hall. Next. Here you can see the faults from Center Hall. So there's a zone temperature fault and some of the plugs have gone offline, it looks like. But again, it kind of shows you the advantage of having that integration from a user standpoint, where now I can see all of those building systems in one place and I'll have to go to different interfaces. Next. I can click on a single floor and now I can see a visual of where these smart plugs are located in the building. And that's quite handy, otherwise it becomes quite an Easter egg hunt once you've deployed these and you're trying to find them in these larger spaces. And so then if I click on a single smart plug, next, I can drill down into specific information from there. So I can see the relay state, the power measurements for this particular load. Next. From here, I can also see trends, schedules, and other activity logs for it. So I can see if it got turned off or became unplugged or anything like that as well. Next. Our next task, once the integration is complete, is to baseline 3 months of data. And then we'll be using the BMS schedules to actuate the plugs for 3 weeks during the summer and fall quarters. So our BMS already has set schedules in there to identify whether the buildings are in occupied or unoccupied modes. And so we can then just translate or copy those schedules onto our plug loads as well. So a pretty easy way to start that energy savings. Next. For task number 3, this is related to the advanced plug load operation. This is what our team at UCSD is just starting to focus on. And there are 2 main buckets for it. The first one is to improve the management process of these smart plugs. And then 2, to implement advanced plug load strategies. Next. So when it comes to management, we really want to address some pain points that we're expecting, but also experiencing right now. And it's really around dealing with a dynamic system. So with typical building systems, they're pretty static, right? You're not adding in new air handlers or moving air handlers around. It's pretty much install and then you're set. With these smart plugs, since they are more portable, it's a little bit more dynamic. So we imagine and already seeing some attached plug loads getting changed. So one day it's a printer, next day it's a coffee machine. And they don't always tell you that. So we need ways to figure that out. Like we mentioned with COVID again, occupants are moving to different spaces and we're having to add new smart plugs and remove other ones. Sometimes we have smart plug load controllers removed or unplugged. There's a group of graduate students in one building that's quite determined to unplug our plug controllers. So we did screw them into the outlet cover there. So hopefully those will not get moved. But we do have those cases. And then, of course, there's also occupant issues as well. So if they come into an office space and they're expecting their printer to be on, but they can't get it to turn on, they're frustrated. Why isn't it turning on? Why is there no power? That needs to be addressed as well. Next. So one tool we're using to address this is Brick. The Brick schema provides a uniform metadata schema for buildings. It's a standard taxonomy and ontology for these building systems and helps define the relationships between them. So you can see in this example here, I have an air handler feeding a VAV, which is feeding a VAV zone and is comprised of rooms. And so now with these smart plugs, I can attach that plug to that specific room and build up these relationships. The other advantage is that if you have multiple buildings, like on our campus, and if they are all following this Brick schema, I can build an application for one building and then use that on another building without having to customize it, because each building may have slightly different vendors and manufacturers for their systems. But again, this provides kind of that abstraction layer over them. Next. This is kind of, again, an overview of the new architecture. So in parallel to the work we're doing with the Metasys system, again, the smart plugs are still talking to that gateway over the wireless network and to that NAE. But now we have a separate server running the Brick server. And again, it will discover those backnet objects. And on top of that brick server, we can then build different applications. And in this case, we have a web UI that we're building right now. Next. Here's a mock-up of that web UI. So you can see how we have a section for service tickets where we can manage different requests that come in from occupants. We're also working on different scripts to be able to automatically generate different service tickets for us. So if a smart plug becomes non-communicating, say, for 36 hours, it'll add it to a service ticket so that we can address that. I'll also look for any unused ones. So if the power measurement is 0, say, for a month, we can imagine that either someone moved out or unplugged something, and we can go move that to a different room. And also looking to add a script to identify those change loads. So again, based on the power measurements in that pattern, we can look and see that there's, this used to be a printer, but now it's a water cooler and has a different pattern. Next. This here is kind of what we envisioned for our maintenance page. Again, having an easier way to manage the metadata around these smart plugs, specifically for when they move. So if they change buildings or room numbers, or the attached load is changed, we want to be able to change that, and you can see that on the right there. We can also turn the smart plugs on and off remotely, and again, that's one way to address those occupant issues more quickly. Next. For advanced plug load strategies, we're taking a risk-based approach. And so I think it's important to remember the prime directive when it comes to building services, and that's that they must serve the occupants and keep them happy. So when we talk about risk, it's about, if an occupant comes in and is expecting the printer to have power, is that available to them? Or do they come in and like, oh, I have to go in and manually override it? So an example of a less risky strategy would be something like a static schedule, where we turn off the plugs in the evenings and weekends when the buildings are unoccupied. So a very low chance that someone will come in and actually need the power when it's off. We can then take other strategies such as location-based or up to a usage schedule, where we look at prior usage and then we can predict when the occupants were more likely to need the load, and then schedule the smart plug to be on or off based on that usage pattern. Next. So as an example of this, we looked at a printer in our library. So this is just one single example, but since we do have a lot of printers, we wanted to take an early look at it. And so you can see on the right here, the red shows the energy measurements over 3 months, and then the blue indicates that the printer is in a usage state. So basically the power measurement went above a certain threshold, and that shows that yes, it is actively printing. Next. So you can see here, if it's in an uncontrolled state, it's using 41 kilowatt hours over this 3-month period. However, next, if we apply a static schedule, we can get to 47% savings in this particular case. And so you can see those white gaps where it's now being turned off during the weekends, and then those smaller white gaps when it's turned off in the evenings. Next. But how can we go further? So just as a very simple approach, we looked at adding the usage to an aggregation map. So every time that the printer is used on a Monday at 10 o'clock, we would add that usage up. And you can kind of see here already the pattern or the opportunities for saving additional energy. So we noticed that over the 3 months, the person here never printed before 10:45 on Mondays. And so rather than having the printers turn on at 6 a.m., can we tighten that upper limit closer to when they actually want to use it? And same thing on Friday, right? Who wants to print on the Friday afternoon, right? So here clearly they haven't printed during that period, and so we could turn it off sooner before that 9 p.m. Standard time. You can also see other patterns such as lunch periods. So if it's greater than an hour, we could also look at saving energy during those periods. And so clearly they never print during lunch, so we could try saving energy during those times. Next. And so if we apply just the upper and lower tightening, so again, nothing in the middle of the day, but just turning them on later in the morning and earlier in the evenings, we can get up to 69% savings. And you can see how those white gaps in the lower graph are much larger now. Next. And then if we look at taking out some of those, like say those lunch periods in the middle of the day, you can get up to 74% savings. So the challenge now, of course, is looking for those outliers and being able to then layer on other systems such as your occupancy sensors to take out additional or gain additional savings. Next. So what are some of the implementation barriers, right? So again, the priority here is to keep occupants satisfied. And the pattern we typically see is that people will choose the safest option, set it and forget it. But let's say that I'm really eager and I do want to save a lot of energy. what's needed for that. And I think this is where you have to keep in mind that you need the right information for the decision, such as the context of that plug load and where it is. You need to get the decision to the decision maker. So even though I might have a great strategy, I still have to talk to the occupant or talk to the department head and say, hey, is it okay for us to apply this new strategy? And so when you think about that, then scalability becomes a really big issue, especially when you're managing thousands of these plug loads. Next. So here's an example. If I look at TVs, a TV in a lobby, a static schedule is probably best because you have people going in and out more frequently. But say a TV in a single occupant offices, a usage schedule might be more appropriate. And again, this comes from the observation that, for example, a printer, I might be in my office, but I'm not really printing all the time. And so I can look at usage and then layer in other factors on top of that. Next. So here's kind of the overall integration or architecture we're looking for. And again, it shows the importance of having these integrations with all these other systems. So getting occupancy from your lighting or occupant information from your facilities information management system and being able to build applications using all of that information in one place. Next. So in summary, some 4 things that we're kind of learning early on right now from our project is 1, make sure you communicate. Again, have emails and have ways for them to directly communicate with you. Like Mark had too, we have a flyer as well that shows them the benefits of the project and how issues can be resolved for those occupants. 2, minimize the steps to resolve issues. I've seen cases where people have the thing of, for an issue, contact your IT department and it just kind of disappears. So we do have a dedicated email for this project and that goes directly to us and we were able to respond much more quickly, which I think adds to occupant satisfaction. 3, be prepared for change, again, and have a process for managing that change. So whether it's moving smart plugs around or tracking the new loads, it's important to have a process in place. And then lastly, be able to make quick optimization decisions by having access to the right information and having decision makers on board. I think, again, otherwise you're going to fall into the trap of just setting it and forgetting it. But if you can have the right information, then you can really get the most out of your smart plug load controllers. So, again, thank you so much for your time and this opportunity to share.
Excellent. Thank you, Keaton. Sorry. Thank you so much, Keaton. This was an amazing presentation and a great example of integration. Okay, so next slide. Now we're going to go into the question and answer section. So at this point, I think all the presenters will put on their cameras. And right now we have questions in the queue for Mark and Keaton. And so I'll go through Mark's first and then I will hit Keaton's next. Okay, so Mark, your first question, how did you coordinate communications and procedures with IT and facilities to deal with issues with the operation and maintenance of these smart devices when you handed off the systems?
Yeah, well, IT was basically only needed in the beginning during commissioning to open up ports on the network switches and things like that to get to the commissioning agent the information they needed. So after that, IT's kind of out of the loop. But as far as operation and maintenance, we have the equipment cut sheets and we have in-house electricians and automation specialists that were involved with the project also. So they have the information needed to troubleshoot any problems that arise. And I also have ongoing contact with the Cree, the company that installed it and commissioned it. So I can contact them if things go horribly awry. But so far, so good on the plug load end.
Excellent. Thanks, Mark. Okay, my next question is for Keaton. Question is, did you notice any differences in plug load control usage or even occupant behavior across the different departments at UCSD?
Yeah, that one's been especially interesting, especially with COVID and the return to learn for UCSD for campus. So we've seen different departments return to campus sooner than others. For example, anything with student services, we've seen them return, but then you can also see their hybrid schedule. So which days they're now on campus and which ones they're working from home. So that's been very interesting, but again, changing a lot as we return to campus still.
Great. Thanks, Keaton. Okay, Mark, I have another question for you. How was the overall experience of integrating plug load controls with lighting controls? Will you be doing this at other Minnesota DOT sites?
Yeah, overall, I think it went pretty well. You know, there were a couple hiccups I mentioned, but I haven't heard anything in the last year or so. So if you haven't heard anything, it's probably working great. So yeah, we do have plug load controls on our new construction. Most of our truck stations aren't as big as this one. They're just small office areas. So we don't really have the networked occupancy detection and occupancy zones and things like that. So it's a little simpler setup with plug load controls. But if we do have another site that has these attributes with the automation system and the different occupancy zones, it's definitely something we would consider in the future.
Great, thanks, Mark. Okay, I have another question for Keaton. On the UCSD project, how many total plug load devices, oh, sorry, let me start over. On the UCSD project, how many total plug devices were installed? And do you know the phantom load of the smart plugs by themselves?
Yeah, so currently we have 744 smart plugs deployed, but we are targeting to get over 1,000 installed. The phantom load of the smart plug themselves actually is negligible. So it's negligible compared to the actual load itself.
Thank you. Another question from Mark. It's about user engagement. How was the project objectives conveyed to building occupants and users for successful implementation?
Yeah, it was conveyed pretty much directly to them. There's only about 20 or 30 people that work there. So communication in our case wasn't as big of a deal as it may have been in Keaton's project, where it's a lot larger scale. So, you know, I spoke directly with the facility manager who relayed that information to the building occupants.
Great, thank you. Then I have a question for any of the speakers. Are there any specific industry standards around connected devices that would make these projects more seamless?
I'll add in a thought here. Again, BACnet has been really helpful since that is an industry standard for building systems. As you guys saw, we are leaning into brick schema for, again, more interoperability between systems. I think the other one that's kind of interesting is the Matter protocol for IoT devices. And I'm excited to see how that may impact building systems for that reason as well.
Great, thank you. Excellent. Well, we're almost at the end of the session, and so I have a couple more, well, one more announcement that I want to make. Any kind of Q&A that we didn't address today, we'll address on when we send out the transcript of today's call. So let's see, Dana, can we go back to the slide? And I think you have one more slide about the Better Building Summit. Yes. Okay, well, before I wrap up, I want to say thank you so much to the speakers. This was an amazing presentation. It really shows what's the next step in building integration and plug load control. So this is a really, really relevant topic, and it's great to see that these technologies have a lot of uptake and really starting to be implemented in different buildings. The last thing I want to talk about today is an announcement for the Better Building Summit. So this Better Building Summit and Better Plant Summit is going to be held in Arlington, Virginia on May 17th through 19th. So the registration is open now, so please register. You'll be engaging with attendees on networking and talking about potential opportunities for energy savings. So make sure that you book your accommodations on the Better Building Solutions Center. That's all that I have for you today. Thank you very much for joining the webinar. And if you have any questions, you can contact me at this email, and we look forward to seeing you on our next webinar, which we do hope to have sometime this summer. Have a great week.